Hello, this is Hui. Welcome to watch my video, C++ programming on Linux. In previous video, it has demonstrated how to write a C++ program that using EVP-PK RSA public and private key algorithm to encrypt or decrypt a message. In this short video, it will discuss another popular usage, the digital signature, which is RSA sign and verify algorithm. A digital signature is a mathematical schema for verifying the authenticity of a digital message or document. The example we are going to use in this short video is a classical concept of a digital signature. Alice sent a document to Bob and asked him to sign the document. Bob signed the document using his private key and create a digital signature file. Bob sent both original file and digital signature file to Alice. After Alice received both the document and the digital signature files, she can use Bob's public key to verify the digital signature to match the original document or not. Here on the Linux, first we make adjustment of EVP class, EVP class.h and EVP class.cpp. In previous video, we create a class called myEVP_key. In this short video, we are going to add 3 methods in this class. The method load to MD will load original file and calculate message digest value MD value. The method pk sign the document using private key. The method pk_verify the signature against the original document. Here is the implementation. Method load to MD will read original file and calculate the message digest value, MD value, and MD length. In previous video, it has explained there are different algorithms that can be used for calculate message digest. In this short video, we just select one of popular algorithms, SHA-256. The function will be EVP_SHA-256. So typically we allocate a memory called in-buffer, and we memory set our in-buffer. We using the bio_new_file function to create a bio for reading the file name from the parameter of this method, and we using the EVP_MD_CTX_new to instantialize context called MD_CTX, and we initialize context MD_CTX algorithm, and we using the default implementation. Then we make a loop, read original file to the in-buffer, and we using the EVP digest update to update our MD context. At the end, we using the EVP digest final function to finalize MD CTX. Then we free our memory, we free our BIO, and return the length of MD values. The pk_sign will sign the original document and generate the signature files. In this method, input is original file, output is the signature files. Return code 1 is success, 0 or negative is fail of creating signatures. First, we declare some variable, return code, signature length, pointer of signature buffer, message digest buffer, and the message digest length, the BIO out. First, we memory set MD buffer. We use our method load to MD, load the original file to generate MD value. If success, then we check our PK. If PK and MD is okay, then we create our context called EVP PK_CTX new. First parameter is the PK, and now it means we use a default implementation. Then we initialize public key algorithm context CTX for sign. Function is EVP PK sign init. Parameter is the CTX. If initialize is okay, then we are going to set up padding. The padding is a random size. Ensure that the same message encrypted multiple times looks different each time. There are few padding models defined in the RSA.h. RSA PK-CS1 padding is one of populars. In this short video, we're going to RSA PK-CS1 padding model. After set up the padding, we are going to set up digest algorithm. We just pick up one of popular EVP_SHA-256 algorithm. The function is called EVP-PK-CTX set signature MD context and algorithm. After finish setting padding and MD algorithm, we are going to doing our signatures. Function is called EVP_PK_sign. First, using this function, second parameter is none. It means we are getting the sign length. The input will be the MD buffer and the MD length, and we returned is signature length. After we get the length, we are going to allocate the memory for this signature buffer. The function which is called OpenSSL _malloc. Size will be the signature _ length. If allocate the memory okay, we are going to this function again to create signature into sign _ buffers. First parameter is the context CTX. Second is the pointer of the sign buffer. Third parameter is the length of signature. Next parameter will be the pointer of MD value and MD length. If a success, we just instantialize a BIO out object. We use BIO write to BIO of a signature, and the size is the signature length. And then we free our BIO. Free the memory, we just allocate it using function OpenSS _ free, and we free the context CTX. We return the RC. Return code is 1, it means success. 0 or negative means failed. Similar to sign method, PK_verify, which verify original file and the signature file if they are matched. The high level of verify signature algorithm first create MD message digest hash of the data file. Second, load signature hash from signature file, and using the signature public key to decrypt the signature files and check that if two hash files are matched or not. Parameter of this method, the input will be the original file and the signature files. The return code 1 means verify OK, 0 or negative verify is not OK. We typically create a two memory, MD buffer, message digest buffer, and the signature buffer. Then we have a return code, MD length, and the signature length. BIO in, which is the BIO for read files. First, we memory set message digest buffer and signature buffers. Then we using the method load to MD, load the original file, and calculate message digest into MD buffer. And if success, we check PK. If PK and MD is okay, then we instantialize object CTX. Then we using initialize public key algorithm context CTX for verify. The function is EVP_PK verify _init. Parameter is the CTX. We set up RSA padding. Function is the PK EVP_PK_CTX set RSA padding CTX. One of popular padding RSA_PK-CS1 padding. And we set up a message digest algorithm. The function is EVP_PK_CTX set signature _MD CTX and the EVP_SHA-256 algorithm. After set up padding and the MD algorithm, we instantialize BIO in, which is from the signature file for reading, and using BIO_read from BIO in to a signature buffers. Then free our BIO after we load the signature we're using evp-pk verify function to verify signature using public key algorithm. The function is evp_pk_verify. First parameter is the CTX, second parameter is the pointer of signature buffer and the signature length, MD buffer and MD length. If return code less than 0, it means signature file and the original file not match. After that, we just free our CTX and return the return code. Now we save our program. After we fix EVP class, we create two programs, one called evp_sign.cpp and evp_verify.cpp. The usage will be the program name. First argument is a key file, which is private key, and the second argument is original document file. Third argument is the signature files. To sign, first we generate a hash of data file from original file. Second, encrypt the hash with private key, produce a signature files. And then we distribute both the date and the signature files. After verify the syntax of input, first we instantialize key object. Class is myEVP_key. We name is key obj. And after that, we're going to load private key pointer of myPK. My method is a load key. Because of sign using private key, so the type is and the file name will be the argument 1. If my PK is non-pointer, it means we load private key file failed. So we just print a message and exit. After we load the key successfully, we can just using the method pkSign. First is the original file, which is the argument 2. And next is the signature files, which is the argument. If return code less or equal 0, it means signature file generator failed. So we print a message. To see generate. Then we complete generator signature file API. Now we save this program. We're going to another program, pk_verify. To verify, first we generate a hash file from data file. Second, we use signer's public key to decrypt the signature files. And we check if two hash files are matched or not. Usage of this program, first is the key file, second argument is the original file, third argument will be the signature files. So after we checked the syntax, first we instantialize our key object. Name is key obj. We have to load key, which is my key equal load the key, and this function first is the key type. When we verify, we use public, and the second is the key file name, which is argument 1. After we load the key, if my PK is non-PTR, it means we load the public key file, not success. So we exit. If we load key success, we can verify using our PK verify method. RSA equal this function. First is original file from the argument 2. Second parameter, the signature file from argument 3. If return code is less or equal 0, it means verify original file and the signature file not match. Else and match. And after that, we just return 0. So this is our signature verify program. We save our program. We compile. We also compile EVP generator RSA key program demonstrated in previous video. Since we are verified, we need using RSA public key and private key. So in order to verify the signature, first we have to generate RSA key using EVP underscore generator RSA key API. We generate our public key and our private key .pem. In order to sign and verify, first we have to create an original document. We just create a text file called myOriginalOffer.txt. So here is a simple text file, like Alice provided the job offer for Bob. So this is our original document. The usage of our sign, which is a sign, my RSA private key, my original offer.txt, and my signature file.dat. See, the generator signature success. Return code is 1, signature length is 256. You can see we have our signature file.dat. It will be the binary file. This is our signature files. And this is our original files. So now we use the verify to verify this signature match or not match. So usage of verify, first is the public key, the my RSA public key.pem. The second argument is original file, which is my original offer.txt. And the third one is the signature file, which is my signature file.dat. You can see verify successfully and the match return code is 1. So if somebody modified my original file, I put a new salary from 35,000 to 250,000. Now we save this file. If we try to verify again, you can see verify failed. This is a typical usage of generate a signature and verify the signatures. This example can also be performed through OpenSSL command lines. The command will be digest minus SHA 256 my private key and the output. Original file is my original offer.txt. You can see we generate API signature files. To verify these signature files, command will be digest minus SHA 256 minus verify key will be the public keys. So my RSA public key.pem minus signature and my original offer.txt. So you can see verify is okay. If we make change of our original offer, we change our salary to 3,050. So our original file offer will be changed. If we run this command again, verification failed. Hello, this is Hui. Thanks to watch my video. Hopefully this is useful and it's going to be great to have your feedback.